Alright, hello everybody, hello from Romania, from your favorite artist electronics KTF. I made a modification because I was getting two segments, A and B, when I was trying to lit up only one single segment. So I was getting double segments. I was getting what is called a glitch, when I try to open only one segment, but another from random position, I don't know why and how, is lighting up by they don't listen to the one that you want to command pretty much, and they lit up like themselves. That is glitching. Ghosting, when some segments are partially lit up, so it's like 20% lit up, they are barely seen, but they are showing something, like it's a very small shadow, very light gray, and they are disappearing slowly when you run everything at fast speed. They are making number 8 pretty much everything if the speed is too high. It's only two problems. So double segments instead of one, it means glitches. It is the same as glitching, but I kind of put it separately, I don't know why. But ghosting and glitches are the main two problems that I'm having. Ghosting, I believe, is mostly from the power supply. If it's too high, the voltage, if it's too high over one segment, it will create that ghosting. So I had this glitching problem more serious than the ghosting. And I had a very smart idea. Actually, I thought of it 2 days, almost about 2 days I stayed and thought of it. So I thought on something. I didn't know exactly how I will proceed, how I will make it work. I really didn't know. But then I thought maybe if I will add something between the shift register and the rest of the circuit, something that I can interrupt, you see, from this enable button that is not connected here right now, but it was connected instead of this line. That is, right now this line is coming directly from the Arduino board and is in relation with the program, with the software. I made a new function here, it's called enable. This enable is opening and closing with a delay. This delay here, this delay. I'll actually upload it to the device. So I made this enable function that is using this delay function there. Is not using the segments per se, but it is used in this, you see, in this digit. At the end of the, instead of the delay, I put the enable. Pretty much what it's doing is doing a double roll. Is enabling this pin here. All the bases are enabled. The base of the gates are enabled through one single clock pulse. So pretty much what I did here is like a memory. It's like a, if you want to say it's a memory, it's like a buffer. But it's like a buffer, not buffering the voltage, but buffering the signal, pretty much. The signal, it's like a gate, exactly like a gate. I'm opening and closing the gate when I need it. So this entire thing is like exactly like a single gate. I was getting those glitches, random segments all over the place when I was switching from one segment to another in the proper order. And they were starting getting some others, guys. And I was starting to suspect that when this shift register is shifting through all these bits here, is actually lighting up this. I thought it is a direct link between shifting all these bits and being powered directly to the display. So pretty much what I did, I made a single gate that is opening and closing. Is closing when everything is shifting, when it's moving here, and when it finished to move. When it reached the final bit that is was sent through this serial line through there, is opening. And this is what this enable is actually doing here. This function is when the segment B is completely shifted, pretty much, and all the bits are moved already. They already finished moving. They are not, so right now, when this function is complete, nothing moves. But while the function is in play, everything is moving here until it's reaching the final bit that is having there. So this is what it's doing. This for this segment B, and then I'm enabling. This is for digit 1 here, but I'm not actually using digit 1. I'm using directly a test. Sorry for that. I'm using directly this code that is pretty much like a backdoor. I'm coding behind the main program. This is the main program. This is the main program here. That is actually dealing with the digits. But here is like a backdoor. I'm using the segments. So when this finishes to count, to shift down, this nothing is enabled. The door is closed. This door is closed. Nothing is passing through these lines to the display. The display is staying dead, pretty much, like you are seeing it right now. It's staying dead. And I will show you actually. Let me give it. Yeah, it is there. So let me compile it a little bit. Finish compile, and now I will play it here in the simulator. I play it. So you see, here it's stopping. It's dead. It's like it's dead. Right now it's very slow. It's very slow, and it's running all this code that you are seeing here, all these segments one by one. Now is segment D. It reached here. Is enabling and disabling in the same time that gate. And so after, let me show you again the enable what it's doing. So the enable, not you. So the enable is when it finished the segment to shift, is enabling that gate with this line, is delaying for a while, depends what delay I'm putting there, depends what delay I'm putting here on the top, and then immediately is turning it off, is opening, is saying on, a little bit of delay to actually display here the segment, and then it's turning the gate off. I'm controlling directly that gate pretty much with this code, and I managed to understand that so this is exactly what it's doing right now, is this enable here, this entire portion of the code, of the circuit, this entire portion of the circuit is is like a gate, and it is enabling and disabling the shifting that is happening, the moving that is happening there. So in this way, I solved the problem of glitching. This, I believe, in my mind, was the principal cause of why this was glitching by itself, without any logic. I mean, I couldn't find other kind of logic. This was the principal suspect. This moving around without any gating, without any door that is closing and opening. All right, so you understood the problem. Let me close the simulation there. And then after I understood, I kind of made an idea what I need to have. Then I start searching for a different shift register. So my shift register is a general purpose, if you want. It's very general. It's not having too much stuff on it. But I said to myself, let me search for other shift registers, and I did search actually on Wikipedia. And after a while of searching, it didn't took me that much time. I was reading the name of the integrated circuit. So I searched for shift registers in an entire list of shift registers from the 74 here, from the 74 series of logic gates. They are a few, and I had to read everyone. I was reading it, what it's having, and at a point I get over this name, shift registers with output latches, and I said, hoppa, output latches. Something is latching there, something is opening and closing like a door. It must do the job, that exactly the thing that I needed here. So I looked into its diagram here. I've seen this part here. I said, this is the gate that is opening and closing. Because why I'm so sure that is the gate? Because we can see here is, I believe, either this or this. One of them, or both of them. I'm not entirely sure. Probably, or this one. These are flip-flops. These are flip-flops, actually. A reset, set, and counter. Here, it means. You see? It's a very basic flip-flop with reset and set and a counter. This is a buffer that is having a very weird... yeah, it's the base of these buffers are exactly as in my... but I was concentrated on this line, actually. I didn't look here. But now, when I'm looking now, it's... Okay, so I did it exactly like they are having it there, but I didn't actually... So by looking on this diagram, I kind of understood is an enable pin that is enabling the output to, after it finished, shift everything inside this flip-flops internally. Then is flip-flopping, all this data is parallel flip-flopping here probably, in this column, and then when you enable from somewhere, there or there, you shift it on the output. And I did made a test with this chip actually, let me find it. If I can find it easily, here it is. So I made, actually the first one I find it was this one, but then I did decided on the other next one because it's not a big difference between them, but it was more popular. I don't know. I chose it by its popularity. I searched for this one, 5994, and I couldn't find it easily. But this one was everywhere. So yeah, I said, okay, if this is everywhere, then people are actually using it. It is the chosen one by many others, so I will choose it as well. So this is, let me run the thing. So when I'm clocking, let's see. So this is data. This is shift clock pulse. This is storage clock pulse, master reset, and output enable. And these 2 bits, I have to leave them alone, not touch them. So I'm shifting. So right now I'm sending only positive signal, data sending. So when I'm shifting inside, nothing shows up on the output. So I press 2 times, and now I'm shifting to 0 on 2, and now I will shift only 1 or 2. It will be 2 plus, 2 minus, and to another 2 plus. And when I'm enabling, shifting the output, pretty much, I'm enabling the output. I'm pushing everything that is already shifted inside. I'm enabling on with a single pulse here, clock pulse, on the output. And this is how it is running. And if I'm pushing it again, nothing happening. It is exactly like I'm having it there. It's here in my other diagram. If I'm pushing it too many times here, it doesn't matter. It's only showing what is on this side. You know, is showing on this. But in my case, it's not retaining the information there. That's why it's having those flip-flops probably internally to actually maintain the data here once it's clocked. So it's getting a positive pulse, and then on the negative is retaining everything because it flip-flopped that data inside. But in my case, it will revert back to negative. It will not stay. It will not retain anything. What I have here. So I have to actually, from code, like I showed you already, from code I have to make it low to actually close that gate, you know, to close it, opening it here, delaying a little bit, and lower it. Probably I will not need this delay in the future, but for now it appears it needs a little bit, a tiny bit of delay for some reason, I don't know, for testing reasons. But I will get to the bottom of it once this will be the thing to run, you know. So pretty much this is the history that I played, and I thought, and I hit my head to the walls to resolve this problem for 2 or 3 or 4 days even, I believe. I had days that I did absolutely nothing. I didn't know what to do. I absolutely was blank in my memory. I was discussing these problems with my English friends, and they were not agreeing with this circuit, with this contraption, this circuit that the entire circuit that I made here. They said this circuit is not for multiplexing. This is only good for static LCDs. A static LCD, or 1 by 1, it's when it's having one single common, not 4 like I'm having here. So one single common and 1 pin per each segment, pretty much. That's the simplest to command LCD possible. It's exactly like a 7-segment LED display. You know, those LEDs with common cathode, common anode LED display red. That they are having some LEDs inside and they are lighting up. But this is an LCD that is commanded a little bit different. So they didn't pay attention to what I did here, because this is exactly driving that. It is exactly for driving the LCD segments. Is not for the logic. This is only this part here that I'm having here is only for displaying the segment. Is not for the logic. Is not cycling through them. Is not affecting any cycling. The speed of the cycling through and the cycling itself through each segment is done by the logic from the Arduino. From here is passing through this gate, and then this stage is only for flipping back and forth. Is for creating the alternative voltage for one segment that is currently sent and show up by the logic that is here. So this is what I did here in Proteus. Oh, here I have the, you see, I have a, it's not a picture, it's actually a program. I can show you, you see, it's a program that I can move it like that. I have it, this is for artists, and it's very good for clean, without any kind of menus. You know, it's extremely minimalistic and extremely clean. And it's very good when I have to show this, to have this pinout of this 3 chips that I'm currently used on my board that I'm having here. So this is what I'm having right now. This is not working. Wait. Yeah. Okay. It's the last code I run it, and as you can see, it is indeed probably a little bit of ghosting. You can see there, but it is tweakable. I am tweaking it from here. I am you know, enabling more. Yeah, probably that's too much. So that's so for some reason, yeah. Another very important detail was these resistors here. You see those resistors, and also here on my diagram here, if I'm not having these resistors here, look what is happening. If I'm cutting them out, and if I'm playing, you see, when it's stopping, I'm getting this full on. Everything is full on, and then it's switching to the correct bit, and then it's full on, and then the next bit, then full on, instead of getting off. So those are critical. I'm very happy I find, let me control Z, control window. So I put them back, and now when I'm playing it again, everything stay off, and only the correct bit is opening. So I inverse the logic that is there, you know, pretty much, and they are critical. But a little bit here, when I'm tweaking from here, you see those, it's starting to show some ghosting. Those are ghosts. They shouldn't be there. When I'm tweaking too much or too high or too low, pretty much. But if I'm tweaking somewhere by looking, you know, I'm looking on it, and if, yeah, somewhere like that, that is good. What this is doing, this is a PWM, as you can read there. This is actually putting a certain voltage, is tweaking the voltage on the segment, and also is alternating by this circuit that is there. But this is controlling the voltage, and I kind of had a little bit of luck by making it, because now in this configuration that I'm having it here is quite helpful right now, and this is very helpful for tweaking a little bit the voltage. And as you can see, at very slow speed, it is showing without any problems, and with the help of those resistors, of course, it's showing without any kind of problem the correct program, the correct segment in its position, and with a little bit of tweaking from there, I'm getting the correct, I'm getting rid of the ghost. And the ghosts primarily are made by, if I'm not having those resistors there. So now the next stage of the problem, because this is by far not finished yet, and okay, let me close this guy here. So now let's get serious about it and put here, instead of 1 second, 1000 milliseconds, let's put 100. Okay, let's get down and program the device. Now we will work directly with the device here, and we will see a little bit of speed increase. All right, and you can see it's flickery and is running, but it's running correctly. This is the most important thing. Let me. But as you notice, the contrast is a little bit grayish right now. It's a bit too gray. It's not black as it was when it was running slowly. Because it's running too fast right now, it's a bit grayish. If I'm talking from here, I can. So right now I'm talking. You see, I pushed a little bit of contrast, but it's also showing some ghosting. If I'm careful, yeah, I kind of balance it to the, you know, to the edge, you know, and yeah, it's kind of okay. It's kind of okay, but the idea is that it will diminish it will lower the intensity of the segment as the frequency increased, pretty much. Okay, so now let's do the next important modification. Let's put 10 milliseconds. And we should not see any flicker, but the problem is another problem. You will see in a second. So when I'm uploading, now the program is uploading. It is finished uploading, and there it is, nothing. And you can see the display, that the bits that are sent there as well are showing. I bet my ass. So this is, it doesn't matter if I'm running from here, from the potentiometer. You kind of see something, but it's like a ghost already, you know, and it's not fully lighting everything. It's doing some funny business right now. Why? Because when I was running it slow, if I was pushing it too hard to the other limit, it was showing some two elements. Let me actually show you. So right now I'm changing it to 100. Program it. Okay, now it's programmed. Now it's finished program. Okay, so now it's back. And now when I'm changing it too much to this side like this, you see I'm getting some random. It's too much voltage on the lines, pretty much on those on the logic lines. It's too much voltage, and it's creating two. And for some reason now it's good, motherfucker. Yeah, but sometimes I'm getting glitching. I'm getting some glitches sometimes, and it's not perfect. It's not perfect by any means. And that's what I wanted to show you. That I'm getting some glitches when I'm moving the potentiometer too far to the margin of it. So now I'm switching to 10 again. Upload the program. 10 milliseconds, and here I'm getting some. So there it's showing me that it's working. This guy that I'm sending data, and I know for sure the data is sent. And now when I'm rotating it back and forth is all that I'm doing. I managed to spike some voltage a little bit in it, you know, and it's showing something, but it's definitely under voltage right now. It's not getting the voltage that it needs, either because the frequency is too high. I have no idea. So I reached this stage where is a problem of frequency, the frequency of the entire circuit. The entire circuit is putting too much, stopping, run and stop, you know, high and low, too many of them, and the display is doesn't know how to deal with it, or some chips from here they don't know how to deal with that lower voltage. Probably is diminishing, the signal is lowering down, and being too low of a signal, these chips are starting to not send the signal further after them on its outputs. I have no idea, but this is the stage that I reached so far, and if I will manage to deal with it, I hope problem will be solved. I really hope so. But I strongly believe that the problem is hardware from now on. It's not software anymore, and it never was software. The program, the code, I mean, you know. All right. Thank you for watching. Thank you for paying attention and being close to this project as I am. I am very curious if this indeed is the circuit that it should be made for a multiplex LCD that I'm having there, or if it's a bugger, or if it's a bug circuit, a very buggy circuit. I am pushing it as hard as I can, and let's hope I will manage to make it work. We'll see. Thank you very much for now. See you later, and wish me luck from the future to now in the past. You know, I will listen to your wishes, and if you don't, wish me good luck. All right, bye-bye from Romania, from our favorite artist electronics, Mr. Q12, who is having a lot of bad experience these days, and it's hot. Right now is in the summer, is in the middle of the summer, and it's too hot. Bye-bye from Q12. All right.